Доктор, а звідки друзі? Це лише в рамках.
The next speaker and the last speaker is Dr. Alexander Hreshchuk, Ukraine.
Андрій, скидали я сюди?
Sorry everyone, hello dear participants. I would like to make a report about design and creation of surface substrates and with nanoparticles they have the shape of stars. So let's start. There's quite a wide range of application of such substrate, like for medicine, biology, ecology, chemistry, etc. You have heard about it, and it's a technique quite young but fast growing and quite interesting. There are also some challenges during such substrate fabrication, such as the complexity of their fabrication, high cost. Some of the substrates give us non-uniform enhancement over the surface. Most of them are disposable in use, and also they are non-universal for different applications. Also, we have some obstacles during the search measurement, such as the photoluminescence from the molecule which we investigate. Also, this molecule can be damaged if the intensity of the radiation is quite big. And we have taken in account that during the search fabrication of the substrates, the lasers which we use in Raman measurements has a fixed wavelength, so we have to consider this to obtain the resonance. So the main purpose of this work is to fabricate the effective source substrates for enhancement of the Raman signal. I want to remind you that there's two main mechanisms of amplification of the Raman signal, such as electromagnetic and chemical. First one is take place by excitation of the surface plasmons in the metallic nanostructures, and the second one is appear when you have the energy charge transfer between the studied molecular and the metallic surface. In this work we have synthesized by colloidal method the gold nanoparticles in the form of stars, as you see on this slide, and the main feature of these nanoparticles is that they have a lot of edge on their surface where the high electromagnetic field could be localized. From this slide you can see that the arrangement of the nanoparticles over the surface is quite dense, and this is the prerequisite of the formation of so-called hot spots, where the closely situated nanoparticles, electromagnetic fields from them could be overlapped, and in these places the intensity of the field could be much higher, and it additionally enhances to the previously mentioned two mechanisms, additional contribution for enhancing. So such morphology you can see, and we have measured the optical spectrum, and you see the absorption maximum is placed on the 600 nanometers, and this this arrows indicates you the valence used in Raman measurements. So we have synthesized nanoparticles taking in the consideration that we will use these lasers. Let's mention you that one laser it didn't pass and fall into the plasmonic absorption band. So in Raman measurement we choose the typical analyte like rhodamine 6G, well known. First we deposit him on the glass substrate with concentration 10 power to minus 3, and on the search substrate with 2 order less concentration. And estimated coefficient of enhancement was 10 power to 4. By using the laser with the wavelength 632, the enhancement was 1.5 higher, and by using the laser this one, we have the enhancement by 100 enhancement still, even when we didn't excite the plasmas. No, not at all, but at some part. Also, we have made the calculation of electromagnetic fields near the nanostructure. We take such morphology and we excite it with different valence of radiation and to have a look on the fields which we obtained near of the edge of this structure. And we have obtained such distribution with the maximum of 600 nanometers. So if we will use such a duration, we will obtain the highest electromagnetic field near the edges. So we could make such conclusions. We obtain the correlation between the morphological, optical, and enhancing properties of such nanostructures, and we have shown that there could be they could enhance the Raman signal from molecules, and the calculation also have been made, and they are in good agreement with experimental data. Thank you everybody for attention. Please ask questions if you have. These samples we can, if somebody is interested in this, we could supply you with these samples. We have a quite new one with better morphology, like the edges are more bigger and sharper. These samples not made by us. Our colleagues from the Institute of Single Crystals in Kharkiv, they made them, the chemists. But we can cooperate if we have some points for work. There was some surfactant. I don't I could tell you later because it's like a complicated name of it. But there was during it's usual for using some surfactant when you use the colloidal method. Yeah, you're right. But there was no signal in Raman measurement from this surfactant. We thought about it because it's typical, because surfactant is quite close to the surface. It's usual the electrical field should enhance this surfactant, but we didn't saw this thing. I will tell you. Yep.
No more questions.
Not enhancement, it's electromagnetic, the value of the field. It's not enhancement. Yeah. Yeah, you're right. Not like 14, it's for 14 times. It's like just the field, and we found where is the highest. We cannot, like in this stage of calculation, we cannot say that how much will be the enhancing. We just feel where is the maximum field on which wavelength. But the value, how much, we cannot say it from these results. It's need like to additional calculation for sketching field. Yeah. Yes. No, we didn't calculate this. Yeah, I understand you. We didn't estimate this. We'll think about it. Thank you. No, it's like not detection limit. It's here we just use different wavelengths and check the intensity of the field, the value of the field. Like in which wavelength will be the highest intensity. Without the estimation of the enhancement factor, it's like we just do it our newest part of the work. Usually we make on the experiment, and this is new for us. We will think to how to improve this part. Thank you. Yeah. This shape was used. Also in this work we have cutted the edge because here we obtain if the edges are very, very fine, we obtain the finite field, not infinite field, so we need to cut it also a little bit. Morphology, yeah. Yes, with changing of morphology, yeah, you're right. Yeah, there is some change. It's well known that with the change of the form, we obtain the difference in the position of the maximum and the shape also. You're right. Yeah.
Sorry, another announcement. As you remember, I promised you the guided tour over the Chernivtsi now. So I guess we would wait another 7 minutes because we are ahead of time and some people wanted to come and just for the sightseeing. So actually we wait maybe 5, 7, maybe 10 minutes, and we start from here. So if you can grab your things, you can do it, but we will wait maybe for, let's wait 10 minutes, and then we start from here directly. We'll see who is coming, and then we'll go together. I think it would take up to 1.5 hours. I try to make it as short as possible. If we are a lot of people, no, you can work. I mean, you can do it afterwards. It's not a problem. It's not a North Korea, I would say. You can work whatever you want. But in principle, yeah. I'll just show you some major and more important things, and maybe some history of the city, because it's still pretty young city, so there is a lot of history. And then we can actually, you can go on your own wherever you want, and that's it. So let's see. My plan was to make it like 1.5 hours at most, but we will see, because I'm not sure how many people we are. Then it may take longer or a bit. Thank you. Просто якщо нас буде дуже багато, то це буде мало змін. Ні, то не автобус, це working. So, for those who didn't realize, it's a working tour, so there is no bus or something. So just estimate it should not be, there is not a long distance to walk, but it's a walking tour, so just take this into account.